Alright, let's talk about the last OOP pillar, polymorphism. And don't worry, it sounds more intimidating than it actually is. It's a Greek word, or two for that matter, poly and morph, meaning many and shape or form. And that's exactly what it is about. One class can have many shapes. For example, the dog class. I have an instance of the dog class at home. His very original name is Bobby. I can refer to this instance of the dog class in multiple ways when I talk about him. I can call him dog. I can call him canine. And I can call him animal. And this all makes some sort of sense because a dog is a dog is a canine, and a dog is an animal. So sure, polymorphism is the ability of a class to take on multiple forms. But how does this work and why is it relevant? First of all, polymorphism can be achieved through inheritance, where a child class inherits the properties and methods of its parent class. Or through something we'll see later, namely interfaces. This all establishes an is-a relationship between classes. Let's go back to our example. We have a parent class animal with an eat method and a few child classes, amongst which cat and dog. Let's create another method eat in both the dog and cat class. So in here, I'm going to say public void eats. And I'm going to say dog is eating. I'm going to do something similar for cats. But you may guess this, I'm going to say cat is eating here. So I'm going to go back right there. What I just did is something called overriding. We'll see this in more detail soon. But both my classes dog and cat now override the behavior of eat. And overriding allows us to create different behaviors for the different subtypes of animals. So let's run this and you will see the more specific method being executed. So is there polymorphism happening here? No, not yet. But if I change this type to animal, now there is. Because what I just did is that I'm referring to my dog with the type of animal. So it's a bit like saying I'm bringing my animal instead of saying I'm bringing my dog. Of course, saying that you bring your dog is more specific, and when you know that you're going to bring your dog, that actually makes more sense than saying I'm bringing my animal. But imagine that this was a sort of crate with a type of animal in it, and I would not know what would be exactly in there. I could have any instance of animal be in a crate and it would work. So this is polymorphism, but if I would give dog a specific method, for example, bark, right now, I can no longer call this on dog. Why not? Well, I only have the methods from animal available. Why is that? Well, because IntelliJ right now doesn't know that my animal is a dog. It knows it's an animal. An animal does not have the method bark. It only has the getters and setters, and it has the method eat. So in order for the dog method to be available, I either must create the instance as dog like this, and then right now I can go ahead and have my dog bark. But if I would change this type to animal, you'll see that it's no longer recognized. It now turns red. Why? Well, there is no bark in animal. What we could do though is we could cast dog to animal. It would look like this. So I need to actually put brackets around this, otherwise it's going to try to cast the void of bark to animal and it can't. And right now I can do this again. But if there's no dog inside this object, this would give a class cast exception. What I can do is I can cast this dog to an actual dog and not to a type of animal. So I would do this like this. I need the extra brackets. Otherwise I'm going to try to cast the result of the bark, which is a void, to dog, and that's not possible. But since it sees that dog is an animal, this is possible. And right now, it will actually work if I run this. It's going to show woof woof. Oh, and the eating, of course. But let's say that at some point somewhere else in the code, something happens to the dog and it gets overwritten by, well, let's say a new cat. And remember, this is allowed. It's very ugly code, but it is allowed. And it is allowed because dog is of type animal, as you can see on line 5. And cat extends animal, so cat is an animal. So in this dog variable, I can actually store a new cat. So this line will go wrong because it's not going to be able to cast my cat to a dog. And what happens then is that we get a class cast exception. OOP cat cannot be cast to class OOP dog. So let's compare it to what I just did. So if I would tell I bring my animal, people won't be able to think of the dog-specific methods. They can only think of animal-specific methods. So animal will probably eat, for example. The people listening would not know that I'm talking about a dog. They might even think I'm talking about my pet tarantula. Well, they would only think this if they wouldn't know me that well. We can use polymorphism to create code that can deal with all the subtypes of a certain type. For example, after uploading documents. The documents might all be of type document, but have their own subtype and have different ways of scanning for problems with the files. The name of the method can be the same, but the implementation can differ. Thanks to polymorphism, we can get away with less lines of code when dealing with this problem, and force all classes of type documents to have a scan content method. Alright, that's enough on polymorphism. It means that we can refer to a class with all its parent classes as well. Let's talk about overriding, overloading and hiding in more detail in the next video.